This is Module 3, Lesson 3, and we're going to start looking at the periodic table today and explaining why all of those mass numbers on the periodic table are all decimal numbers. So right here is an example of the periodic table, and you can see how all of these mass numbers that are on here, like 1.08, 6.941, most of these lower numbers that are larger in each of the squares are decimal numbers. Now, that's not true of all of them, because obviously if you get down here, I do see some whole numbers. But why are they decimal numbers? We discussed in the previous lesson that you can't have like 0.2 neutrons, so then how do we come up with all of these? Well, there's a reason for that. So, first of all, these are weighted averages. The mass numbers on the periodic table are not in grams. So when you see a box on the periodic table like hydrogen, and it says that it has a mass of 1.008, that is not 1.008 grams for an atom of hydrogen. That is 1.008 atomic mass units, or AMUs. And the definition of an AMU is seriously a 12th the mass of a carbon-12 atom. Like, that is the standard for what an AMU is. So that is much, 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 much smaller than a whole gram. A gram is about the mass of a paperclip, and for one atom to have that much mass is a definite no. So they're weighted averages of the isotopes. And so a weighted average means you take the mass of each isotope and you multiply it by how often it occurs. So I have some examples for you as to what I mean. So here are the naturally occurring isotopes of lithium. Okay, we've learned about isotopes. We know that when we see this dash, these are the masses. So lithium-6 has an atomic mass of 6.02 AMUs, and lithium-7 has an atomic mass of 7.02 AMUs. The 6 occurs 7.5% of the time, which is not all that often, and the 92.5% is belonging to lithium-7. So here is how we do this, and you're going to have some practice with this coming up. What we're going to do is we are going to take the mass, and we're going to multiply it by the percent abundance. Now, this is multiplying by a percent. So you either need to use the percent button on your calculator, or you need to divide it by 100 first so that you get the right numbers. You're not just going to multiply it by 7.5. If I multiply it by 7.5%, I get 0.4515. Because what I did in my calculator was I went ahead and divided this by 100, and oops, I haven't done that in a while. I moved it over, and so I knew that I would have I would multiply by 0.075. I'm do the same thing with this one. I'm going to multiply 7.02 times 92.5%, or 0.925. So I'm doing this as we do it, 7.02 times 0.925. That equals 6.4935. Okay, what do we do now? We add. We add those up. So I add those up, and I will get 6.945. This would be the weighted average of lithium. What that did was that made it be very close to 7. And we can do kind of a little self-check and say, is that appropriate? Well, yes. If 92.5% of the time you have 7, then my weighted average should be very close to 7. This pulls it down just a tad. How about another example? Sometimes you have a lot of different isotopes that occur. So here we have the naturally occurring isotopes of sulfur, and you can see that the overwhelming majority is 31.97. And then you have a little bit of some of these other ones. Well, what that tells me is that when I do my weighted average, it should come out pretty close, I would think, to 32, since most of the time this is what occurs. If I come up with an average that's like 33, 34, 35, those don't even make up, much more than 5%. That doesn't make a lot of sense. So let's do it. We're going to multiply these two. We're going to have 31.97 times 0.9493. Okay, that comes out to be 30.349121. Then we do the next one. We'll do 32.97 times 0.0076. That is 0.250572. Then we will do this one. And you could do this all in your calculator at once if you want to and put parentheses around each of them. I'm just kind of doing it in steps. We'll have this one times 0.0429. That equals 1.457313. And then we have our last one. We have 35.97 times 0.0002, which is not going to be a lot. That equals 0.007194. Now we add all those together. So I'm adding. It would be a lot faster if I just put parentheses around all of them, but it is what it is. And I get an answer of 32.0642. This would be my weighted average of sulfur. Now we could check and see how that compares to the periodic table. This says 32.07 right here, and we got 32.06. That's very, very close. If we are dealing with slightly different numbers given to us, we might come up with something slightly different. And one thing that you don't realize just by looking at this is that not every periodic table rounds to the same place. Ours gives us 2 decimal places. Some of these have 3. I've seen periodic tables where they only give you like 2, some give you 3, some give you 4. These are rounded numbers too. They've just rounded them off to a couple of decimal places. Okay, so I have practice for you to do where you find your own weighted averages to make sure that you're used to doing this. The last little thing is just a couple of words about the periodic table. We've been talking about it off and on here. Something to just make yourself aware of is that the atomic number is always whole, and I said earlier the mass number is almost always a decimal. 2 other words that you need to know are the words period and group. Period is the official term for the horizontal rows, and group is the official term for the vertical columns. We're going to learn more about periods and groups when we get to a later module. We'll talk about periodic trends and the periodic table itself. But go ahead and know that if you're going to refer to this and tell someone that iron is in column number 8, the technical term for that would be group. It's in group 8. And that hydrogen is in period 1, which means row 1. Lithium is in period 2. So try to use those words as we move forward. Now it's time for you to go to your practice and see what you can do with weighted averages.